Subscribe and click the notification bell to stay updated with the latest videos from School of Technology, Management and Engineering and MIMS in.
A very good morning to everyone present here. I, Manas Sharma, take immense pleasure in extending a very warm welcome on behalf of NMIMS, School of Technology, Management and Engineering family Indore. I welcome you all to AICTE Training and Learning Faculty Development Program on Internet of Things. The first session for the day will be on data utilization in Internet of Things, IoT. Before beginning the session, I would like to inform you all that a feedback form will be shared in the chat box. So I request you to fill in the necessary details correctly, as the attendance will be provided on the basis of the submission of the form only. Internet of Things holds different meaning for different people. It goes from concepts to reality. One of the biggest challenges is how the data created by devices will flow through the system. Some of the topics which will be discussed in today's session are data processing and visualization via IoT, provision of privacy and security, simultaneous working of cloud with IoT. I feel extremely honored to introduce you all to our expert, Dr. Sonali Chouhan. She is currently working as a senior faculty in Indian Institute of Technology, Guwahati. Dr. Sonali received her PhD from Indian Institute of Technology, Delhi in 2009. Since 2010, she has been in the Department of Electronics and Electrical Engineering in IIT Guwahati. She has researched on various topics and authored multiple chapters focusing on the energy efficiency of various communication techniques. Dr. Chouhan was a recipient of the Microsoft Outstanding Young Faculty Award in 2010 for India for EU Postdoctoral Fellowship, Reviewer, and IEEE Transaction on Wireless Communications. We feel privileged to have you today with us, ma'am. I now request ma'am to share her valuable thoughts with the audience.
Thank you, Manas, for a brief introduction. And I'll start my presentation. So good morning, all of you. Let me know whether my screen and presentation is visible to you or not. I hope it is visible now.
Yes, ma'am.
Okay, so it's a great day. Good morning, everyone. Today we are going to talk about IoT and data related to it. How do we differentiate IoT as compared to other networks? Why data acquisition is important here? And what can we do to do so? So because it's not a regular network, that's why we have to think about different strategies. So I'll give an introduction, and beyond that, we'll build that why data acquisition is important here, and what are the challenges. In addition to that, what techniques we can adapt, and so on. So feel free to ask questions whenever you have. Okay. So here, what we say is that I'm quoting here Mark Weiser. He said that the most profound technologies are those that disappear. They weave themselves into the fabric of everyday life until they are indistinguishable from it. Okay, so yeah, that's really great to see. Reason being, many technologies we now find that they are part of our life. For example, mobile phone has become a very integrated part of our life, and IoT is also going towards it. So this is what is we are aiming using IoT, that in everyday life we won't be able to say that this is IoT or that is IoT. For example, earlier embedded technology, embedded systems came in, but now it's very difficult to tell you that, okay, I can't distinguish that this is embedded because it's at so many places. Similarly, IoT is also moving towards it. So in cyber physical domain, you see that what are the things. So here we have marked 5 things. One is that your data volume. We'll talk about it just in a while. But before that, we touch upon other 4 points here. So one is societal impact and economic values and viability. So for any technology, you actually adapt it when it has a great value in both ways. One is it is touching to the society, and second is economically also it is allowing us to advance. So many services and applications will come into picture for doing that purpose. But when it comes, you have to implement it. And when you implement it, you implement using some networking and communication. So we know that these devices are wireless, they are segregated, so they are not physically connected. So, but still we have to communicate. And finally, to communicate, we have to make a network of it. But when you form a network of such so many devices, you are also worried about security, reliability. Of course, privacy is another concern, because initially when we try as a toy examples, we say that it's all fine. But later on, we when we really use it for our important applications, we are also concerned about the privacy. And finally, when we collect all these things together, lots of volume of data gets collected. So how to deal with it? How to handle that amount of data? Can we identify some specific characteristic of that data which differentiate it from conventional data handling? Because we all are very much aware that data communication is nothing new, which is happening since long. And as a teacher, we are teaching that to our students. But why now again we are talking about that data? So we'll talk about it today in little bit detail. So there are multiple sensor devices which are available now. So what kind of sensors we have? We have sensors for monitoring your motion. You can monitor that how many steps you have taken. You can also monitor some physical statistics of your environment. For example, you can measure the light intensity, you can measure the temperature, and so on. So, but what is different over here? It's not a simple sensor. These devices are are also incorporating some memory. They are also incorporating some hardware which can make it programmable. So you can program based on your requirement, for example, and sometimes these are event sensitive as well. So depending on the purpose, the programming can be done to make it sensitive towards the events happening, or time measures. For example, I can program that you measure the quantity of interest every hour or every 6 hours or every day and so on. Or what I can do is I can also program it to monitor when the event happens. For example, when I wear a smartwatch or a wristband, which can calculate how many steps I have taken. I don't have to switch it on or off. Simply, whenever I take a step, that's an input as an event, and it keeps on measuring it, right? So that way, it becomes quite comfortable for us to to monitor things which we want to monitor. Okay, and these are mostly now off the shelf gadgets or tools, so you don't have to build them from scratch. But still, to form a network, to make more sense out of it, we can use them together, and that's where we are going to see that how these are going to form networks over here. Okay, so not only few things, but like as I gave an example of a wristband, that is a singular device. But can I not have more devices? Yes, more things are getting connected. And when more things are getting connected, you have to connect them, you have to manage them, you have to deal with how they are going to talk to each other and who's going to talk to whom, kind of. Okay, so this is going to now change the scenario of our home daily life. Not only that, but businesses and public infrastructure is also going to get affected by it, plus healthcare. So in COVID time, we have seen that healthcare has also improved a lot. And yes, it has immense scope still to improve and to provide services without being in contact with somebody else physically. So this is not only going to be helpful when COVID type of situation is there, but also in future when traveling is really expensive, not only in terms of money, but in terms of efforts, in terms of time as well. So if one has to travel 50 kilometers from a rural area to urban area just to consult a doctor, all these efforts are like he has to spend one full day, and his productivity gets affected. If he can get that remote access to the services at his place using IoT, definitely he can improve his productivity in another area. So that way, this is not going to only be applicable in one scenario, but in multiple scenarios, this is going to be very useful. What is happening? Initially, what has happened, that what we said, that yes, I can wear some sensors on my body and then that can be measured locally. Not only that can be measured locally, but that can also be measured on some other device, remote device. So what can be done is all these sensors can send data to one device in vicinity, and that device particularly can be connected to the internet. For example, I can have a mobile phone which is synced with these devices, which keeps on collecting the data. And as the mobile phone is connected to the internet, it can relay the data, and it can be stored on the edge, fog or cloud, depending on how we are configuring it. Okay, so this is an example of people connecting with things. But another scenario or paradigm is things connecting to things. Okay, so how do we do it? We do it simply by, for example, a smart car. So what smart car does is it connects the sensors in a car without any manual intervention to another car or to the traffic management system. So that way, there is no manual intervention which we require right now. Yes, you must be listening or reading to the news items where automated cars are being fined or monitored as nobody was there. But ultimately, the objective of making such cars is that one person need not pay attention on driving, right? So this is a very basic tendency or basic objective with which these technologies are being developed. Of course, they are not in their final stage, and we can't rely right now on the machine fully, but we want to rely on the machine fully. That's what is our objective. And therefore, we say that these are some complex networks and resources, plus they are also quite tedious in terms of networking. So these networks are not that simple to form because many challenges have come in with the new scenario. For example, if you are talking about connected watch versus connected cars, very basic difference here is that the mobility. So my watch, if I am connecting five watches of my family members, they are not moving at a very high speed. Let us say that when they are in home, relatively the cars are always at higher speeds. So there are associated challenges which we have to keep in mind. Okay. So we have heard of earlier wireless sensor networks. Sometimes this question arises very often, that what is the difference? What is the difference between wireless sensor networks and IoT? Is it not the same thing? Is it not the renaming of the old technology? But yes, there is a fine difference which we need to pay attention to. Here I have drawn a network where you can see on the left that there are sensor nodes. Okay, and they are connecting to some sync node. What is a sync? We'll talk about it in little bit detail little later. Okay, so sync, you can say, is something which is collecting the data. Finally, there may be a gateway which is connecting to a core network. And that core network could be internet, that could be another sensor network of the similar type, of different type, and so on. And finally, these core networks are being formed by end users, different devices. Devices could be your mobile, devices could be your computers, it could be your tablets, and so on. Okay, so one may say that this is IoT. Yes, this is IoT. But in when it was conceptualized as wireless sensor network, the focus was on local domain data collection. And then finally, how that data goes to internet was not that primary there. Yes, it could be connected, but when we see IoT, you can say that this is like formation of networks of different wireless sensor networks. Okay. Here, one thing which we need not miss is that these usually run on small devices and these are low power devices. Okay. So therefore, our focus of this talk would be, as and when required, would be on the how much energy they are consuming. Okay. So why is it important? Because they are wireless, so they are working mostly on battery. Why do I say mostly? Why not I say always? Reason being, sometimes they can be also powered with solar power, but usually all these things are quite mixed up. I mean to say, you may not rely fully on battery, you may not rely fully on solar power as well. So sometimes there are hybrid modes as well. But most of the time, the easiest way or the cheapest technology right now is to provide the power by using battery. Okay. So I don't want to change batteries very often, and therefore it's quite difficult, or I should say annoying, if I have to replace batteries very soon or I have to recharge them. So it is expensive at one end. Also, it is not very convenient. And sometimes it is also not possible. You imagine I have deployed some nodes to monitor um, activity mm, around a volcano. So there I may not be having a reach to the area. I can go with an helicopter, simply disperse them in the area, and if it is not active, so I would like to monitor as and when what happens after the volcano is, let us say, is in sleeping mode. It's not active, but occasionally it may be having some activities. So if I want to monitor it, it's not a very feasible area to go, and therefore I won't be even possible to go over there. I can give you more examples. For example, I deploy them to monitor the forest activities. So when I deploy them from over the air, I don't know where those nodes are going, and therefore not possible for me to trace it back and replace the battery. Imagine another situation where it is used in battlefield, has been deployed in the battlefield as a small tiny node where nobody can notice it, and it's relaying the data of the surroundings. So that also maybe that also will be something which will not be possible for us to collect back. Okay, so this is kind of a one-time deployment. Okay, and then how we see them differently. How do we what are the characteristics here we are looking for? Okay, so when we see these small examples of these networks, there can be extensions to it, which is saying that okay, more nodes, more connections. And another dimension coming over here is not only about place, not only about time, but also about things. So anytime, any place, anything. So that's what we can say that can be a definition of IoT. Okay. So people have also envisioned this as M2M, which is machine to machine communication. But broadly, the broader term which we can use is Internet of Things over here. And here we are not talking about few devices, few hundred devices or thousand devices. We are talking about billions of interconnected devices. Okay. And everybody is connected. This is what is the vision over here. And expansion is also happening from the infrastructure perspective. For example, your broadband is providing you a very good bandwidth for communicating more data. Also, the newer technologies in 5G or in forthcoming 6G will be providing the very good infrastructure in all the form. For example, not only the physical infrastructure, but also the logical infrastructure. For example, if we look into LTE, which is the latest standard for 5G communication, so which in fact in 5G it has been, there is a community which is called 3GPP. Okay, so what they are doing is they are making things more concrete. They are not leaving things hanging in the air. Instead, they are making things more concrete by giving specifications. What frequency range will be used, what kind of modulation will be used, what kind of compression techniques will be used, what type of techniques will be used to make it more reliable. For example, what kind of error control codes will be used, LDPC or turbo codes, and so on. So they are looking into different aspects and then providing some guidelines. So every year, more or less every year, we can say that they issue a release. Like last year in July, they issued the release 18 of 3GPP. So there you will find that they have specified many things, not only IoT, of course. They are specifying it for, of course, your mobile communication specific independently. They are also looking into the edge computing, but they are also focusing on IoT there. So what protocols are to be used? How, what are the specifications? What are the values of those parameters which are defined in the protocols, and so on. So lots of expansions are happening, and it is a multidimensional thing. It is not a unidirectional thing, because I cannot implement an IoT without a infrastructure to communicate. When I say infrastructure to communicate, not only communicate, but lots of data I have to communicate. So can I be having some reliability? Second aspect is not only I want to communicate data, lots of data, but also I want to communicate it in a shorter span of time. So latency is something which is also important there. So all the things which are getting evolved right now are going to enhance the current networks, and we can call them later on the smart networks. What smartness do they have? They have some artificial intelligence. They are being implemented using some machine learning techniques. So therefore we can call them smart networks. So they can evolve, they can learn, and then they can implement that knowledge in an unforeseen situation, so which has earlier not occurred. They can still see, and they can predict that how to handle it. And these are not only the connection oriented networks, but they are more focused towards data centric and content oriented networking. Because and we'll see some examples also, some interesting examples which will make this point clear, that what is data centric, how is it different than regular networks, which there also we communicate data, right? So keep thinking how data centric networks are different than regular networks, because in both the networks you are going to communicate data. So why are we calling it data centric? So I'll come to this question again later on. By that time, you also keep on thinking that why should we call it a different network? Why is it? How is it different? Okay, and these are some having context awareness as well. So because I give an example, context is very important. Some words are there in English, which are also there in Hindi. For example, suffer. Okay, so Hindi, Urdu, whatever you call it. So here, what is happening when I call it suffer? So it what does it say? It depends on my context, right? So it's like whether it is a suffering or whether it is a travel. So it is a context dependent information. Information is same, but if I do not know in what context this word has been said, two languages may have the same word, but they have different interpretation. How can we know that what was being said over there? It depends on the context, in which language it was spoken. Even if it is not the language, but then in which context it was spoken. When we mix the languages at the time also, it is important that you understand the context. So therefore here, context awareness is important. And if a network can learn about the context, it can become an autonomous one. You don't need to intervene, you don't need to tell it. So some intelligence is also which is on the top of the infrastructure, physical hardware. Intelligence is also being incorporated in these networks. Okay. So when things got connected to things, we thought about things connecting to internet. And if you see here, we have contrasted the number of people versus things. So previously, you see that this brown circle is representing people and blue is representing things. So earlier the ratio was people were more, things were less. But now the situation is just opposite. There are less number of people, but more number of devices. Why do we say so? You see yourself how many devices you hold right now. Not only one, but multiple. In your home, if you'll see, definitely there would be more devices which are connecting to internet than number of people residing in home. So this is the paradigm shift. This is what is changing the whole scenario over here, where we are, earlier we were having more number of people, but few devices. Right now, things are very different. That devices are many, many more and much more, and they are growing to be more even in future. Okay. So how do we define IoT? So formally, people have tried to define, but I understand that we have a feeling what IoT is. So people thought that why not we extend the current internet and provide the connection, communication, and internetworking between devices and physical objects. Okay, so we called everything a thing right now. So we may become a thing at one point of time if we also wear some sensors. Okay. Another definition was given in terms of technologies and solutions, which is going to integrate the real world data and services into the current information network. So ultimately, the bottom line thing here is real world data and services. What is real world? Real world has its own challenges. Just as I said, that I cannot wait for an information for a very long time because I have to further take decisions based on it. So my network might be very much focused only on collecting data, but I'm also focused on or concerned about how long you take to collect that data, how long you take to interpret that data, and so on. Okay. So these are the challenges which we have to keep in mind. So if we see the evolution here, evolution is something going to be like this. Pre-internet, we were more human to human connected. Then internet came in. Finally, the services came in which are using internet, and internet of people, which is social media. And finally, we are talking about internet of things. So internet of things means they are going to be communications from machine to machine. So what is happening? Earlier, there was a human to human communication, and in that, in between, the devices were helping. But in future, what we may envision is the devices will talk and only human will help it. Because you see, the proportion of devices is much more as compared to humans. So it's a total change in your surroundings, the way it is happening. So of course, all these evolution, all these changes have happened by adding some smartness to it. But over the time, how and between what the smartness has been used and at what level the smartness has been used has keep on changing. Like earlier it was for IT platforms, then phones came in, then devices are coming in, and now you have to add more intelligence to learn what to communicate, because data has been growing a lot, and that is becoming a big concern over here. So of course, we all know that why we need to look into IoT, why we need IoT, because many emerging technologies are based on such implementations, and in different areas, the IoT services are growing. Not only as a smart city or healthcare, but also in logistics, transport, retail, safety, and so on. Also, this is bringing in multiple business trends and new opportunities. So what is there which we by using what we can unlock the potential of IoT? So of course, it's going to give you better performances at reduced cost, and new type of services will be available. And this whole ecosystem is going to provide you the new revenue streams. Okay, of course, without economics, you cannot talk about anything which is more fruitful, because you have to run the whole system. So unless and until this is productive, it's not going to last for long. For example, if you see that anything which is non-productive will ultimately die down, because there is no motivation to keep on running it. So some of the things might be looking unproductive to you, but it might be productive for somebody else. That's why people are putting in effort. For example, if you see the online games, you might see that this is not enhancing any productivity of yours, but of course, some other people are getting benefited, and that's why economically they are getting benefited, and that's why they are putting in effort in making such lucrative games for you. Okay, so what are the technology trends over here? So trends are something like over the time, we started by having RFID tags. So they expedited the logistics, and also they incorporated the technology in a manner that seamlessly things can be tracked down. And today you can see that RFID tags are kind of not visible to you. Can you tell me some examples in the chat box where do you see RFID tag in your regular life? Can you write down few examples which you have seen? Toll collection, great, yes. Anyone else? Shopping malls, yes, to track the items, yes. What else? Mall, yes. Anyone else? Employee attendance card, great, good. Track goods in malls, yes, we have been using it for tracking goods. Anywhere else? Okay, so mostly we have seen it in our day-to-day life at two places which people could recall. One is in the shopping malls where they put a RFID tag with your clothes and merchandise. And second is at the toll plaza. There is also one more example which are being used at some places in libraries. So in nowadays the books are also being RFID tagged, so that without human intervention you can borrow the books, you can return the books. Simply you need to have you need to have RFID readers over there and some database which can be connected with it. So yes, these are some great things which has started, which has happened. Okay, but at the same time you see that over the time what has happened, we moved on to from static things to mobile things. We went on to the surveillance, security, healthcare things. So we went on building devices which are less costly. So therefore, they could help us in vertical market applications. Later on, we went on locating devices and people in a broader area, and therefore they could be applied anywhere, everywhere. Okay. Next was the physical world web. So which we say that, okay, miniaturization has happened. They became smaller and smaller, and also they could be able to communicate at a longer and larger distances. Like my mobile phone, yes, they are becoming larger and larger, because for us it is difficult to see on smaller screen. But at the same time, you see your smartwatch, that is a smaller device. Okay, even there are some shoes which are available with some sensors which are embedded in the sole part, so that it can monitor how you walk, and particularly those are very useful for runners, athletes, which can the data can be utilized and is being utilized by the experts to tell that what techniques he should adapt, because now we are in a world where your physical strength and your stamina matters, but beyond that techniques also matter. So therefore all these sensors are sometimes not visible, but they are being used. And finally we are going towards Internet of Things, where we are connecting everything everything and communicating with it at multiple places. Okay. So, as I said earlier also that number of people are now less, devices are more. So here, when we say that, okay, more devices, the first consequences here is that lot many applications and lots of data. Here you see that we have shown that in 60 seconds all over the world, how many activities are being done in terms of data. So you can visualize that how much data is being produced. For example, in 60 seconds time, around 7 lakh hours of video is being watched on YouTube. Okay. And if you see the Google's stat, so around 4 million searches are being done in 60 seconds time. So this is something which will give you an idea that this is not a small world. And I'm only talking about right now YouTube and Google. What about Facebook? Lot many hours of video content is being watched, around 70,000 hours. And similarly, photographs are also being uploaded. Not only that, some chats are also going on. So text messages are being shared. On WhatsApp also similar situation is there. 29 million messages are being processed, 1 million photographs are being uploaded, and 175,000 video messages are being shared. So this is not something which is small, and this is within 60 seconds time. So if you track down your watch, 1 minute time is nothing, but within that, lot many applications are generating lots of data, and therefore we want to pay attention on how to deal with it. Okay. So global data generation is something like around 20 quintillion bytes of data is being produced every day. So 10 raised to power 18 bytes are being generated. And this data includes textual context. So what is textual context? Basically, sometimes we also put tags with your data. Okay. So something is beyond data. So data is to identify data. For example, when I search Google for images, so of course there are some tagging associated with those images. Otherwise, images are non-searchable. But unless and until you have some tagging, you cannot search. But if you have tagging with it, that this is relating to this particular, that particular tag, then that becomes more and more searchable from that perspective. Okay. Then multimedia content is there. Multimedia content is something which is in forms of images, videos, audios, and of course on variety of platforms. Right now we are sharing it. So what is the data life cycle? Life cycle starts from data collection. Of course, first stage is to collect data. So what is the context here? Context, so as I said that we would like to tag data. So we call that tagging as metadata. Okay. So I'll take an example of metadata when we'll talk about metadata related data segregation. So some context you have to put. Sometimes we put metadata as a context. Sometimes we put ID as a context. Sometimes location or time is the context. For example, I can have different types of queries. I can have a query which says that, okay, what is happening around you? Around you means I am more concerned about location. Okay. So what is the latest event in your location? Contrary to that, I can have a different kind of a query. That at all, as we are sitting online, I am sure that we are all sitting at different geographical locations. And what I can query is that what happened at your place last hour. So, or I can say that today, 8 o'clock, within the 8 and 9, 1 hour duration, what happened at your place. So here the context is time, not the place, because places are changing, but time duration remains the same. Similarly, I can also provide you an ID, like you are a teacher or you are a professor or you are a student. So based on that, I can put a query that what was the activity of a professor in that hour, or what is the activity of students in that hour. Okay. Sometimes we also provide IDs to sensors. So I can also query based on what is the activity or what is the input from the XYZ ID sensor. Okay. And fourth, here is metadata. So metadata is basically an intelligence way of having your database. So there what you do is you provide some context to your data. So data may be collected anywhere, anytime with any ID, but I want to segregate it in different manner. For example, I can ask a query that in your classroom, in X subject, what was the performance? Similarly, I can also ask that for X subject, what was the performance? What is the difference between first question and second question? In first question, I put two conditions. In your classroom, X subject, and then performance in that subject. Okay. But in second question, I removed in your classroom. That subject might be taught by different people in different classrooms. So now if I'm saying that on X subject versus the performance, so it is like a collected subject performance everywhere. Okay. So the metadata is very helpful in those kind of queries. If I provide a proper metadata with the data, I can actually, I can dig the data or I can curate the data in a much better manner. Second thing which comes while we are collecting the data is validation. How do we validate? Based on the source, whether it is a valid source or not, whether based on the range. So within this range only I want the data, and another could be the format. Is it in the right format or not? Based on that, validation needs to be done. So one thing is you provide a context. Second is you validate. So you can't keep on taking all data which is coming your way. You have to see that what you really want. And finally, you do the verification. Verification in terms of accuracy, consistency, integrity. How do you measure the accuracy? What you transmitted and what I received. Are they the same thing? Are they the same? Are the data provided by you or sent by you and the data received by me is same? So can you tell me a metric in the chat box which can give you this accuracy? Any metric which you have seen or read which tells me this particular verification of accuracy? What comes to your mind to verify the accuracy? I'm sure you must have used that metric multiple number of times. Can you write it in chat box? I rephrase the question. You transmitted 100 bits of data. I received those 100 bits of data. And now I'm trying to see whether those bits are the same as you transmitted or not. So which metric am I supposed to use to find it out? No? Nobody? Identity metrics. Okay. No, not really. Parity check. Okay. Yeah, this is closer. Anyone else? Validation. No, we are talking about verification right now, not validation. Validation and verification are two different things, right? I'm asking which metric will you use? CRC. Okay. CRC, parity check. Yeah, they are closer to what I'm talking about. But they are not metric, they are methods. They are the techniques to measure a particular metric. Okay, I tell you that is bit error rate, BER, right? Because when you see that what you transmitted with what I received, I compare these two and see how many bits are in error. And to reduce errors or to make things better, we use CRC or parity check. So parity check will tell me whether error has happened or not, but how many errors have happened, that is something which is important for me. The reason is I have some level of tolerance towards errors, but not, I cannot work if everything goes wrong, right? So I have to keep a check on accuracy. Similarly, I also have to keep a check on consistency because if once data came correct, I need another data also to be correct in the same manner. So consistency is important. Plus integrity is also important. So it is not that you simply keep on sending me data, but there is no reliability in it. Reliability should be there and consistency should be there. So all these things are needed to be checked, and this is something which we classify as verification. Second stage of data is, let us say we have collected data. Then we go for analyzing the data. So data analytics will be in terms of computation. So for computation, you store, you index them, you aggregate, and you have some structure and so on. And then you go with correlation. So correlation is also a good form of your data analytics, because this allows you to take some decisions based on based on what your type of data. Okay, so if two data is correlated, can you make something out of it? Or if they are totally uncorrelated, can you make something out of it, and so on. So here we do benchmarking. We also do here the profiling, and also we take based on this informed decision. So example of profiling is I take the data and then I see that what kind of characteristics it has. For example, a parallel example I can give from a simple program, that I can profile a C program, and that profiler will tell me multiple things. For example, it can tell me that how many number of times a loop is being generated if I run the profile for a part or segment of the program. So what am I trying to do over there? I'm trying to identify what are the characteristics of this program. Similarly, for data also I can do the profiling. What kind of data it is? Does this has any specific characteristic? Because if you can identify a characteristic, you are actually closer to finding out a specific solution to it. Okay, and then comes your analytics in terms of compliance, that you should control the quality, and of course governance, skill, competence, all those compliances will come with the data analytics. Finally comes the data use or reuse. So you can use that data for your own purposes or sharing purposes. So here what actions you are going to take based on the interfaces, visualization. So all those needs to be formed. And secondary use can also be seen, but at the same time we also need to be aware of risks, precautions, what kind of rights are there, what kind of licenses are provided, and so on. So usually what happens is that your devices can collect data, but from stage 2 onwards, for stage 2 and 3, the other the bodies should come in. For data analytics, yes, some organizations or some people can come together. And mostly for stage 3, mostly the larger bodies, for example, government comes into the picture. It will form the guidelines that how this data is being shared. For example, for machine to machine data transfer, government is forming guidelines. So who should, some licensed vendor should provide these kind of services. It cannot be anonymous, because there are multiple dimensions in which one has to think, and that is a larger dimension. Like it could be a security threat. If you allow one device to connect to another device without any service provider, you can imagine that anything can be communicated which can be harmful for the purpose. So those kind of things are to be evaluated by a larger bodies like governments, and they usually do so, and accordingly they regulate things. Okay. So ultimately what we want to do here is we want to transform the raw data to insights and actionable knowledge. Okay, so we want to interpret something out of it. We are not simply interested in data. we are interested in something more over here. And once you do so, you're also concerned about the effective representation forms for the machine. So machines can understand as well as humans can understand. So something which both can understand well. So this is going to lead to automation very well. Okay. So what it requires is hold this exercise of understanding data. We require more data for it. Okay. So and also we require it from multiple sources. And we want to do it as realistic as possible. So near real-time analytics we want. Plus we also want to have some visualization and some symmetric representation. So all these things needs to be done with the data. For example, what is the example of visualization? Imagine I give you data for let us say 5 persons, and I say that the performance of first in running was 2 minutes. It took 2 minutes to cover a distance d. Second one required 2.5 minutes. Third one required 3 minutes, and so on. Okay. Fourth one also required 2.5 to 3, and so 3.5. So I give you data for 10 persons. So right now it might not make much sense to you, because you see, I'm giving you different data for different persons, and those are different people. But what can I get out of it? Can I make a graph of it? When I make a graph of it, what I see is they are more or less close to each other. Minimal is 2.5, maximal is or minimal is 2, and maximum is 3.5. Now I'll also process the data and make it what is the average time people take. There may be some outlier, so I may be interested in it. And so there starts the story. I collect the data, then I have some way of visualizing, analyzing it. So multiple times you will see that people try to show things in terms of graphs in different ways: pie chart, bar chart, or line charts, depending on how you want to visualize, because visualization helps us a lot in understanding the whole lot of data. Okay. So IoT is evolving, no doubt about it. And finally, when these devices comes into picture, we also have to store data somewhere, because volume is too much and my devices are very small. So cloud comes into picture. And nowadays, not only cloud, but edge computing is also coming into picture. But as that's not a focus of our today's talk, we will not go into detail of it. So what are the applications which we can see? We all start from intelligent home, right? That's the first example I bet that everyone must have heard of while talking about IoT. But this is not something which is the end of the world. This is just the start of world. This is something which we can correlate to very easily. But I'll show you some very interesting examples. Uh, for example, structural health monitoring is important. This is a motivation slide. What has happened in real life? This whole bridge collapsed one day. Reason, it was being weak, and as nobody knew that this is becoming weaker and weaker. So manual inspections happen periodically after 6 months, 1 year, and so on. But in the meantime, if something happens, nobody knows what's happening. So what we want to do here is that we want to avoid the continuous and manual processes, plus those may be expensive processes. So what IoT can do, it can make it feasible that yes, continuously you monitor. Second, it can be very inexpensive as well. So once you have deployed it, you can utilize it for longer duration. So it becomes less and less costlier. Okay. For environment monitoring, we can capture the images. Here we have taken an example of camera traps used for counting how many lions are there, how many tigers are there. Okay. So what we do here is that we capture the images by using camera traps. And to do the counting, we use the software. Okay. So you may say that what software will tell you? Basically, it can identify some things which are different for each and every animal. For example, two lions will not have similar type of marks, their leg marks, but at the same time, they also have very distinctive feature in terms of their facial parts, which as a common person, we do not identify, okay? So using softwares, there is a Wildlife Institute of India, which is implementing so many such kind of projects where they collect data, then they utilize, and uh, they also develop such kind of softwares which can be used in identifying them differently. Okay. So what is a camera trap? Camera trap basically is a device which looks something like this. So it has been mounted on a tree, and you know that I can't keep on monitoring the area like CCTV full time, because how much data it is going to produce, you can imagine. With CCTVs also, the problem is that how much data you are going to store. So same problem could have been here. So what people have thought, that why not we make it event based? What is the event? If something comes in front of it, or it activates and takes the snap. Otherwise, other times if there is no major activity, you do not take any snap. So this camera trap basically identifies if some activity happening. If happening, it will take the picture. So of course, you are not going to get pictures of the only the animal you are interested in, like lion or tiger. Others will also come in front of it, but we can always segregate it later on. Okay. So with the help of this camera traps, world's largest camera trap wildlife survey was conducted for the tiger population in India. Okay. And in 2018, it is found that they are around 3,000 uh, in their population. Contrast to in 2006, they were around 1,400 only. Okay. So these automated methods are going to make, because one may say that what is there in counting, but if you know at the time that how many are there, then you can do, you can take steps to make them safe, to see that their numbers are going up or down. So based on that, you know that something wrong is happening. So you can stop doing those things and you can protect them. So there are multiple things which can be done with these numbers, but to obtain these numbers manually is a very difficult task. What happens, people are employed, they are being made aware that how to read and how to see, how to differentiate their step marks, foot marks, and then based on that they do the calculation. Some will be missed as well, of course, but here in this trapping method, most of them might be captured, and it's more reliable, more continuous, and also less tiresome. So this is something which we can also see as a IoT application. Then in environment, we can also have some acoustic monitoring done. And it's important because this is non-invasive. Instead of this device, if a person goes in there, all the things will be disturbed because he is not invisible, right? Compared to human beings, these sensors, devices are kind of, they get embedded in the environment. They don't move, they don't harm anybody. So that way, these are more accurate and more, you can say that more effective. Another example is remote sensing with LiDAR. LiDAR is the latest technology which is being used for multiple purposes, including knowing the forestation, deforestation, so density of forest, and so on, using technology. Also, this is an example of ZebraNet, where they have put in collars on zebra for studying their behavior in Kenya. Then medical applications, of course, are there. So multiple technologies are being developed, multiple devices are being developed. So Intel has deployed a 130 node network to monitor the activity of a residents in an elder care facility. and the data is being acquired with the wearable sensing nodes, okay, the watch over there. You can also use these devices for knowing that whether they are active, whether they are not falling, because elderly people have different problems. So if they are living alone or not with many people around, these devices might be very helpful in knowing remotely that how is the state. Then of course, precision agriculture is something which is also we want to implement IoT for, which will actually aim to make this farming more efficient and reducing the environmental impact. So instead of doing it for masses, see, if you don't have resources, what you do for everything. But if you know things more specifically, you can instead of just doing it as you do every time, you can modulate it. You can make it plus or minus over there. Like how much water should I provide? Based on the humidity, you can change the level. And you can also collect multiple information, like when the crop is being ripened. For example, for grapes, it's very important that at what stage they are getting ripened, because based on that, the further products are very much affected. Okay, so the information collected by the sensors will be used for evaluating the optimum sowing density, estimating the fertilizers and other inputs which are needed over there. Then biomedical or medical applications are of course important. You must have seen the robotic surgeries are becoming common. Like for bypass also now they can do the robotic surgery. So multiple areas they are being they are being used and implanted. Okay. In military also, tactical monitoring is something which is important, where the small sensor nodes can be deployed in the area of interest, and then that area can be monitored continuously. Of course, industrial and commercial domains are not untouched. By taking the RFID example, we have actually seen the industrial application, where we are talking about malls. Similarly, in industry also, you can have tagging of different boxes, goods, and you can do the inventory tracking. If commercially also these can be implemented. I tell you one example, like if you are transporting a vaccine, let us say the corona vaccine, and that needs to be kept below a threshold temperature. So yes, you can make a box where it is lower than the temperature, but let us say I'm transporting it over the air to some other country. So I need to monitor continuously that the temperature has been maintained below the threshold level. Because even if for some time that temperature goes up, your vaccine is actually not effective and that is harmful. So what you need to do there is, in logistic, you have to incorporate the sensors, and not only it has to tell you that the temperature threshold has been crossed. In fact, you have to tell much before then the threshold is being crossed. You have to tell that it is going to cross the threshold, so that you can take some corrective actions before it spoils the vaccine. So there are multiple ways you can utilize these techniques. Of course, traffic management and monitoring is something important. Like here on the left upper corner, I have shown one example where one sensor you can see in circle. So what it can do is, it's a simple application. If some car is going to be parked over it, it will sense and tell that this parking slot is full. Otherwise, it is empty. So you can show on some board that which are the slots available, and accordingly drivers can drive the car over there to park it. Similarly, our cars are becoming more connected. Now you see that it can tell you when your seat belt is not put on properly, or if your doors are open, and many more things which are very simple applications, but still those are being embedded here to improve the safety. But we envision that they are going to be much more intricate applications over here. Like one car can tell other car that the traffic is slower over there, or some accident has happened, so jam is over there, so change your route and so on. Okay. So from wireless sensor network to IoT, we came a long way. And in this example, we have shown the disaster management where different sensors are being used. You see here, you see the solar panel to provide the power. And these are some connections and some sensors are also being shown. So what is happening that to know whether avalanche is going to happen or landslide is going to happen, because we see and that in multiple parts of our country also avalanche happens, or sometimes the road landslide happens. So in that many a times people's lives are being lost. So to avoid it, what can be done is you can keep on monitoring the prone area for that activity, and you, if you know that this is the threshold beyond which things may go wrong, you can stop people from being there. So those kind of activities can be monitored. Here we have shown that on the x-axis, the time is there, and y-axis, some activities you see that because some airplane went in, so some different type of data collection happened. So in frequency range, you see that it is going up for a very short duration of time. For avalanche, it is lower in frequency, but for a longer duration. For helicopter, you see that it keeps on waving like this. So once you have identified different types of signatures, you know that what activity is happening over there, and accordingly you can take an action. This is another one, which is automatic weather station in Austria, and data is being recorded over there by the sensors over there. And of course, efficient waste management in smart cities is being implemented at multiple places for collecting the data, collecting the garbage, collecting other goods in a smarter way. And this is IoT and WSN together, which says that, okay, at the physical layer, you have sensors which are sensing data. Now you are going to the transport layer where you have the IoT management platform. And finally, this is going over the application layer for the utilization. Okay. And we also have sometimes gateways. Whenever we have, instead of flat, we implement the networks in hierarchical manner, we usually rely on gateways. Gateways collect the data from sensors and then relay it to another places. Okay. Okay. So this is a full IoT ecosystem where in-field edge nodes or the sensor nodes will collect data. It will go on transferring it to local servers, which are known as the fog servers or edge servers. And finally, later on, that can be relayed to the cloud. Why not directly to cloud? Because sometimes the cloud servers may be very far away and may not be a good idea to directly relay the data to the clouds over there. Okay. So what are the factors which influence the IoT device? Of course, scalability is one point. I have to connect so many devices. Fault tolerance is another. If one device fails, can still my network survive? If n number of devices fail, can still my network survive, and so on? What is the cost of production? What are the hardware constraints? We'll talk about this hardware constraint just now after this, okay? What is the topology of my network? What is the operating environment? How much is the power consumption? Where this power consumption happening, and so on. So these are the broad technologies which has happened, which has made it possible. One is sensing. So this is very tightly coupled to the physical world. Finally, we network them, and also we have some embedding there based on our requirements. So numerous distributed devices can be embedded in the environment and then network together to coordinate and perform the higher level tasks. So specifically, if we see where power goes in, so we start from the sensor node or IoT node. Here we have shown that these are the major parts of any node. Battery is there to provide the power supply, right? Then sensors are there, which are sensing the physical quantity, converting them from analog to digital and giving it to microprocessor. So here we have formed the 1 unit out of microprocessor plus memory. Why we are distinguishing? Because microprocessor and memory are more or less, they cannot be separated out. But in power consumption or energy consumption, you'll see that memory consumes a very significant part and also microprocessor. Microprocessor runs the program, memory stores the data, but storing data itself is expensive in terms of power. And then comes the radio part. So out of these 4 units, in any application, yes, battery would remain same. Once I decide that what kind of power am I going to have, I can simply have larger or smaller battery. But once I have decided this is the form factor of my device, more or less battery also gets decided. Sensors will be decided by the application. But I have something to play with here in these 2 units. One is microprocessor unit, another one is your or I call it a computation unit, and second is your radio unit or communication unit. So radio also has some parts in it. One is hardware part, which is related to different filters, different power amplifiers. So hardware part of radio. Also, it has one more part which is different, which is RF part. So how much power am I transmitting in the air? That makes the total power consumption. So I cannot forget 2, because here power amplifier is a hardware device which actually consumes power in proportion to the RF power I am going to transmit in the air. So based on that, we have to compute that how much power it is consuming. Why we are talking about it, I show you in the next slide that these devices, small devices, when you measure how much power they are consuming or energy they are consuming. So we have measured this energy consumption in a sensor node like this I have shown earlier. What we found is whenever you are not even doing any computation or transmitting data, some base energy will consume because the device has to be on. It has to be ready to do the task, right? So multiple components are on, so base energy is more than 50%. And when you are only communicating and then we reduce the base part, we see that approximately 25% is going in the radio part and around 20% is going in the computation part. So here, whatever you do, can you reduce the radio and computation part so that total this colored part is reduced? If it can be reduced, you can say that, okay, I'm saving the energy. And this is also to show that radio and computations are very comparable to each other. And if they are comparable, you can play with it. Play with it in the sense that I can put some part in computation little bit and reduce more part in radio. Can I do these kind of trade-offs or not? So this is a realistic picture of any small device. So we have to be careful not only about how much am I communicating, so and also how much am I computing. So what kind of computation are you going to do? We'll see just in a while. Okay. So different sensors and actuators are available to us, and in market n number of sensors are available. Based on your requirement, you can purchase one, and mostly these devices are made in a plug and play manner. So the connectors are generic. You can simply bring one or the other and you can put it in the corresponding plug. Things are everything together. All the parts I have just now shown are part of your things: sensors, microcontroller, communication, and power supply. Okay. Usually the major properties here are they are battery powered and they are limited in energy, and size and cost is low over here, and they do not perform very complicated tasks on the board, on the sensors. Okay. Okay. So main design issue is your power consumption, and you must be aware as you are attending this FDP. So you know that different devices are available for implementing your IoT. You can utilize it, and in your laboratory you can form this kind of network very well, this kind of connection very well by using the breadboards and jumpers. So this is a ground reality, but ultimately when you connect things in real world, you get in these some of these devices, you also get the transmitter, receivers, and things embedded on the device, on the node itself. So Finally comes the communication. When you have collected the data, you would like to communicate. You can communicate it using different techniques, different technologies available based on how long you want to, how far you want to communicate. For short distances, usually your RFID or ZigBee will do. But for longer distances, you have to go with your cellular technologies like 3G, 4G, 5G. And sometimes some specific techniques are also available for forming smaller networks like WiMAX kind. Okay. So you choose accordingly, and based on that, you choose your protocol as well. Once network has been formed, it is going to connect them, and then it can be used for data collection. Of course, you have to pay attention for reliability and performance over there. Okay. And ultimately, the internet is going to provide you the way to transport data and save data somewhere in a bigger device. Okay. So here we are showing just the protocol stack. At some places, protocol stack could include higher layers. At some places, there's no need, because you see that application layers are available in the source and destination, but intermediate routing devices do not require application layer. There is nobody to look into it, but they require something which is needed for routing it up to the network layer. Okay. Okay. So security and privacy is something which is important, and you have to every time evaluate what is the risk and what are the challenges. So challenges from the security perspective also comes at different level, like device level, network level, system level, and user level. So you have to prevent it at different levels so that your network is secure and provides you guaranteed privacy. And different software platforms and services are available. For example, for IoT devices, Contiki or TinyOS are the popular operating systems. If your devices are small, actually they provide you a low complexity operating system with protocols. And many relevant protocols are also being developed and coming into picture. For example, 6LoWPAN is something which is developed for IoT requirements. COAP is there. And based on these devices requirement, architectures and other hardwares are being promoted and made. Okay. So these are some examples. So here we have shown two parts. So I'll not tell you what is the difference. I would like to show you the two pictures and animation, and you tell me what difference do you see in the top one and the lower one. Okay. So you see, in the top one, data was transmitted from the sender and it is received by the receiver. Okay. In the lower one, fire happened and ultimately it is being communicated to the end user using some data. So do you see any difference in both the networks? Are they same? First of all, whether they are same or different. Do you see any difference? In the top one, we transmitted data, received data. In the lower one also, we transmitted data and received data, but based on some event happened. So do you see any difference here? Anyone would like to write it down in the chat box? Lower one is local. Okay. Infrastructure needed is more in case one. No, I'm talking from the perspective of the data type. Do you see any difference? See, in previous one also we are communicating data, in the lower one also we are communicating data. Can you see any difference here? Okay, yes. Even triggered data in lower network. We can say so, yes. Anything else you notice over here? Meshing in lower network. No, I'm not talking about topology. I'm concerned here about type of data. Of course, both are communicating data, but do you see any difference? Or other way around, if I ask that in the top one, do you know what it was communicated using data? We do not know, right? But lower one communicates that there is fire. So this is what is the underlying difference over here, that we are more interested here in terms of what is the event, what is happening, right? Not like I'm just not interested in some bits 0 1 0 1 0 1, but I want to make something out of it. So that is where the difference comes in. Regular data communication, you can keep on communicating data, but sometimes we are not interested in data, but the information in that data. How is it different? For communicating information also you have to communicate data, fine, but not always what has been produced will be communicated here, okay? So that is what is the difference over here. So we need to do some intelligent data processing, like you have to sense and collect the data, fine. In data centric network, you are more focused on the data. So collecting data, storing data, not only that, but you have to have some kind of access to that data, some subscription need to be there. So some integration needs to be done in the form of how to access data, how to access information. And can you make some queries? Let us say I have stored data of temperature of my room for 24 hours. But later on, I want to know what was the highest temperature. I want to know what was the minimum temperature. I want to know what was the average temperature. So all these queries should be, we should be able to answer. It's not like that now it becomes a garbage. I can't make out anything out of it, okay? So you need to do classification of data and also some clustering of data based on your requirement. So we have things, we have data, and we have lots of it altogether. So we have to deal with this volume and we have to see that how can we do so. Simply transmitting data from one end to another end is not the solution. So we need to do something so that we can handle this volume which is being generated and which is going to be generated. Okay. So, and also it's not that each data is not important. For example, here you see we have one anomaly and we may be interested in only this anomaly. Reason being, this is something which is of our concern. So each single data item is important, simply you can't lose it. But I also cannot transmit each and everything without knowing the background, without knowing the context. It sometimes become a garbage. So I have to make it more and more sensible. Okay. So what are the challenges in data collection? Or one is whether it is a multimodal or heterogeneous kind of a network, whether the data also contains noise, whether it is complete or not, should we go for some interpolation for it, and is it time or location dependent, or sometimes your data itself cannot be reliable because you are doing the crowdsourcing and some of the information providers might not be providing you the true data. And of course, privacy and security are important issues. And sometimes data can be biased because where our focus is based on that only we see. Like I go into a room searching for, let us say, a key. So what I do, I simply keep on searching for key. So I might not be noticing other things which are around me. Second time, when you ask me that, have you seen a toy? I might not notice it unless and until it is very distinct because my focus was on key, not on the toy. So in the same manner, data can be biased. What we what type of data we have, we need to know, and accordingly we have to take corrective actions over there. And bottom line here is people want answers, not numbers. Here in this infographics, what we have shown here is question was what is the temperature? But I don't want actually to know the temperature. I want to know whether it is cold or it is warm. So if answer is freezing, I'm happy with it. I am not interested whether it is 30 degree or 29 degree, right? Or it is 16 degree or 15 degrees or 12 degree or -2 degree, because it should make some sense to me. If I do not know how to interpret it, -2 means cold or much colder or freezing. If I don't understand this, that number makes no sense to me. So here more focus is on the interpretation, what this data is and what it is conveying. This helps us in actually reducing the amount of data also. Otherwise, you can see this is one of the data centers. For storing, handling, and processing data, we require this huge infrastructure, and it consumes lots of power, and it's not a small thing. Okay, so there can be some semantic technologies for connecting the IoT. For example, you can have some metadata models. What is metadata? Let me explain. If I am collecting data for let us say, okay, I again take the example of, let us say we are in a school where we have 5 sections of a class, let us say class 12, okay, and also I have from class 1 to class 12, of course. So, but we focus on class 9 onwards, for example, okay. So what happens is, if I say that, okay, what is one person data can be identified in different manner. Let us say there is a student, Ram. So what I do is I simply ask that what was the average of maths subject for class 12. So what will we do? We will actually include each and every student who has taken the math subject in class 12 from all the 5 sections, and then we will give the answer. In that, Ram's data is included. Contrary to that, if I ask that, okay, what is the average of class 12 overall? So all the 5 sections data for all the subjects will be taken. In that also, Ram's math subject is included. Another query could be, in your school from 9 to 12, what is the stat for math subject? So what will you do? You will actually take the data from class 9, 10, 11, 12 and the students who have taken math subject, and then out of it you will make some statistical analysis. Like what was the minimum, what was the maximum, what was the average, how many passed, how many failed, and so on. Okay. So the metadata basically is very helpful over there. So the maths data can be classified in the form of maths itself. So one mark is there, which is a math data, but math, in addition to that, also we need to provide a metadata that which class. Another metadata we can provide is it is for which section. We can also provide the metadata in terms of whether it is for the female or the male student. So based on the type of query, I can provide different metadata for one particular number, and that would be very helpful. When I now put the queries, it can answer those queries. Okay. And similarly, you can have data linking, and you can link all those IoT data concepts here. So this is something related to correlation. Many a times what we observe is your data is very much correlated if they are it is being generated at the same place. Okay. We also have to see the interoperability issues, because from one device to another device I have to communicate, and those two devices might not be same. So can we handle if the type of data is different over there? So these are all things which we need to do and process data in these manners, so that we can actually utilize it in a better manner. Okay. Okay. And this is an example where your different devices are communicating for interoperability. Okay. So for observation and measurement of data, what we are doing is taken an example that we are measuring it at a remote place, then communicating it and doing some estimation. Okay. And once we have done, we will then find out some property out of it. Let us say salinity is the key interest, property of interest over here. So that can be measured and it can be stored also for future use. That what was the change in salinity level in that particular area or something. So for doing so, what we need to do is uh, we have to optimize things. So for data collection, what could be the optimization goal? One is quality of service. So quality of service means it could be measured in conventional network in terms of throughput, delay, or jitter. But in IoT, this is something little bit more complicated. Like you have to also consider whether the event has happened or not. So event detection and reporting probability need to be monitored. So how many times the event has happened and out of that, how many times the network could detect and report it. An example of this kind of event detection is I am monitoring, let us say, a fence, and I want to monitor an intruder. So if I keep on continuously sending the video feed to the observation station, one person is required to see it continuously, right? Instead of that, I can also do one thing. When I find that activity is happening more than the threshold, why more than threshold? Why not I say that 0 and 1? Because there can be some trees which will be moving. So if I simply compare the previous frame and next frame, of course there would be changes. It cannot be very static scenario. If I am observing a open area where some trees are there, some birds are flying. So, but I don't want to trigger the system when the trees are moving or the birds are flying. But I want to trigger it when a human intervention is happening, when a person is trying to break the fence and come inside. Okay. So looking at it, what you can do is you can make a system where it will send the data only when the event has happened. Very similar to what we have done in the trap cameras. Okay, but little bit more complicated. But because here the thing is not 1 and 0, and also we have to make sense out of it. If slow movements are there, also if cat comes in, I don't want to raise a false alarm. So all those things will be required to know. So therefore, how many times you are detecting correctly? Is it false detection happening more or less? Because sometimes you will miss the event. Sometimes you will unnecessarily trigger the event. Like when a dog will come and if you say that, okay, the intrusion happened, it's a false alarm, right? So what is the approximation accuracy here? And what is the tracking accuracy? So all those things are more important because this is more focused towards what data is communicating. Okay. And robustness is also something which is important in case of IoT. Another goal is energy efficiency. Why? Because ultimately your network should survive to collect data. If you spend too much of energy and your nodes are not available, they die down, you won't have anything to collect, anything to interpret. Okay. So therefore, network lifetime is something important, and this is being measured in various ways. Like sometimes people measure it as something which when my first node dies, or sometimes people say, okay, even if one node dies, I don't mind it. I can simply say that network when my network reached its half life, when 50% of nodes are died. Sometimes we also measure that when 10% of nodes are remaining. So it's like almost all the nodes are died. Another way can be that when 10% of the nodes are died. Okay. What is the time when I lost the coverage? When my network got partitioned? When what was the time till the time I could not detect anything? So first event was notified at what time? So depending on our requirement or our focus, we can define the network lifetime itself in multiple ways. So we have to see that which metric suits me more, and accordingly we can measure it and then see whether it is whether it can be improved further or not. Then another goal is scalability. Scalability because number is going to grow. I have already given you a glimpse of numbers, so you know that we are not talking about small number but big numbers. So can my methods work for a larger network? When in classroom we do experiments or when we teach things, we usually try to take simpler examples because that is the first step to learn. But ultimately, when we are developing something, when we are proposing something, when we are focusing on something, we need to also see whether in future it is still relevant or not. So scalability is something which we need to think about seriously. These are different IoT scenarios based on source and sinks. It's a simple one where one source is there, one sink is there, directly connected. Sometimes it is multi-hop connected. Different type of sinks can be there. Sink could be another node of the same time. Sink could be your mobile phone. Sink could be ultimately a base station through your mobile phone. There can be multiple sink, multiple source scenario. There can be multiple sources with one sink. There can be one source providing information to multiple sink or mixed all together. There can be networks with single hop and multiple hop. So one common problem here is that your range of communication is usually very limited. So how do you communicate to all those is something which is important. And if you go into the specifics of the communication, if you are aware of it, you must be knowing that depending on the environment, your path loss varies. More the clearer the environment, lesser losses are there. More cluttered the environment, more losses are there. Okay. So what can you do if it is not reachable? You can go for multi-hopping. Here you see that even though physically these source and sinks are not very far away, but there is an obstacle in between. So therefore, the way is you go through other nodes. Sometimes even though you can reach to it directly, you may not want to do so. Reason being, your when you communicate to a larger distance, usually uh, your energy or power you require is proportional to at least d to the power 2 or in general d raised to power n. More the distance, more the power, but it is not a linear relationship. This is an exponential relationship because your path loss exponent n, if it is 2 or more, usually for open air it is 2 and for cluttered environment could be 3, 4, 5, even could go up to 6. So you can imagine if I double the distance based on that exponent, the power is going to be not double but much more than that. Okay. If it is 2, then it is going to be only 4 times. So this is not just the same as changing the distance and changing the power. So multi-hop sometimes is useful, but as time doesn't permit us, I'm not going into the details here. But bottom line here is if we compute the power when we directly communicate versus we compute the power or energy when we communicate through multiple hops, which is going to be better. So there is no one single answer. Reason being how they are placed, based on it, things will be decided. But not only distance is playing a role, but also what difference is coming. Here you see on the top, you transmitted once and you received one. In minimum energy transmission energy or multi-hop transmission, you will see that you have transmitted not only once, but n minus one number of times, and also you have received those many number of times. So although I am saving in terms of transmitted power, but I am spending much more in terms of number of transmissions happening and receptions happening. So I have to actually make a call when this threshold is crossed and when multi-hop transmission is beneficial. Okay. So by doing the comparative analysis, we can do, this is a simplistic analysis, although where we have just taken that some electronic components will be on as I have shown earlier, and some amplifier would be consuming energy based on how much power I am going to transmit. So when we do this comparison, we get some comparative where it shows that, okay, I know the R value, the distance between two nodes. I know that what is the number of hops over here. And I also know that how much is the energy being consumed in the electronic part and amplifier part. Then I can always compare that when I should go for transmission directly or with multi-hop. Okay. So you see, a simple decision also requires lots of computations, lots of accuracy, because if you do not consider all the components important, you will make a wrong decision, which you don't want to do. Now, different sources of mobility also plays a important role, and also they also poses lots of challenges. Okay, so nodes can be mobile, we can imagine it, but sync can be mobile, we can also imagine it, but sometimes event can also be mobile. Can you imagine it? See, so we want to we are here saying that, okay, my sync is mobile. So I am collecting data using a mobile phone of mine, and if I am moving in a car or jeep or even by walking, then I am moving myself, but sources are static. Relatively, you can have a event also mobile. Like here we have shown a pink elephant is moving. So tell me where the pink elephant is. So earlier pink elephant was here, later on it was here. So my source and sinks are not moving, but my event itself is moving. So overall whole stack of my whole topology or whole equation of my source sink actually changes by event mobility also. So we have to keep that also in mind. So to handle data, what we can do is we can do in-network processing. So in-network processing actually is manipulating or the processing the data, because bottom line is I want information. Okay. So my one example could be aggregation. For example, minimum, maximum. So if I'm already interested in minimum, maximum, what I can do is instead of transmitting the whole observed data, I can compute the minimum and only communicate one, or let us say three stat. One is min, max, and ultimately average or something, or outlier. What was the single point which was maximum? What was the single point which was minimum? What was the what is the variance over here or something. So what you are doing is you are not communicating 100 data points. You are actually communicating only 4 or 5. But what cost you are paying for it? You are computing. So that's why when we say that computation can reduce your communication, but it's not free. We have shown it also consumes significant energy. So you have to see that whether it is really worth sending only 5 by doing computation, or whether it is worth sending all 100 data points and server can compute. So as a designer, as a network designer, you have to take that call. Okay. Another, here we have shown an example for the aggregation. What aggregation does here is, you see that different nodes are transmitting data. So one points are there. Here 3 data points have been collected itself plus 2 more. And finally 6 data points are being transmitted. Relatively, if we simply do the aggregation here, out of 3, 1 has been transmitted. Here also out of 3, 1 has been transmitted. And ultimately we have received only 1 data point for the sync in the sync. Another could be signal processing. For example, edge detection is another technique. So it can do the geometric identification of the phenomena which we are sensing. Okay. So it could be like you can have a example is you can have a microphone array which can compute the angle of the single source. So it will communicate only the angle but not the raw data. So it will tell me that, okay, from where I get the better data and from where I do not get. It could be having only one characteristic, it could be multiple. So it is like I have shown here the single phenomena topology where one phenomena edge has been computed. So inside there may be a little bit variation, but we know that within this range only this phenomena exists. For multi-phenomena also multiple ranges have been shown. So we know that this is the range of our concern. And accordingly, I can make queries. Instead of sending the whole data, we are just sending the edge of this data. it could be like we can also exploit the temporal and spatial correlation. So in time or in space, if they are correlated, you can utilize it. In data networks, your spatial correlation is very important. You can do the correlated data, utilize that for network coding. So all those techniques are basically used based on spatial correlation, because we know that in a room, if I measure or monitor the temperature, I'll find that more or less the closer nodes are giving me correlated data. So instead of transmitting each and every data, I can utilize that correlation in some for my benefit. Another thing I can do over here is I can send the only the difference. Like unless and until this is different than previous data by a threshold, I'm not transmitting. So that kind of an approach also reduce your data. You can also do it based on event. So when an event happens, only then you transmit, not every time. We have taken a elaborated example earlier also. Okay. So when your difference is, let us say, more than delta, you can transmit. If it is less than delta, do not transmit. There can also be either within that also further changes or further thresholds, smaller threshold, larger threshold. You can have two threshold. One is hard threshold, another one is soft threshold. So those are very pretty interesting techniques to handle data, and you don't need to then transmit lots of data. But bottom line is you are doing some sort of computation and then reducing communication. So you have to weigh which way is better. Don't do it blindly. Sometimes it may end up in giving you more energy consumption because you computed a lot, but you haven't saved in proportion. Okay. So these are data-centric networks, and therefore, contrary to node-centric conventional network, newer techniques can be adapted here. And my more focus is on data. So I can do what, I don't care who generated this data many a times. So therefore, I can do averaging. I can do all the processing which we have just now talked about. Okay. So these are some more detailed technique. For example, you can have distributed hash table, DHTs. So hash tables basically are like content addressable memory and something similar to metadata thing, where you have the key value pairs are there, and based on that your queries can be made faster. There is also one more interesting way is publishing and subscribing mode. So it is something like every node has data or its gateway has its local aggregator or gateway has data, and then it publishes. So whenever you want to get that data, you have to subscribe to it. Something like newspaper subscription. Everybody is printing its newspaper, but you get only one which you subscribe to. Similarly, here also multiple data is being generated, but you get the data which you subscribe. I'm on the same sensor, I have the temperature sensor, I have the humidity sensor, I have the light sensor, but I subscribe only to the light, then I get only the data related to light, not the other two. So that is a publish subscribe model. So in data centric networks, publish subscribe is also a very good way of reducing the data communicated. Otherwise, you keep on communicating each and everything to everyone, your network will die very fast. So what are the challenges finally? Of course, connectivity is first thing. Second is your power and energy management. Security is there. And ultimately, we can say that volume of data is going to make your life even more complicated. So you have to think of different ways. So if you can identify the characteristic of data accordingly, you can make decisions and you can process your data accordingly, and then you can transmit less amount of data, but same information can be gathered with less amount of data. Okay. So with that, I conclude today's session. Okay. Overall, the Internet of Things right now, what we see is something like only a tip of an iceberg. Smaller part of a very large part which is still not being implemented. We have many things to do over here. And I thank you all for your patient listening, and those who have interacted over the chat. Thank you, all of you. If you have any questions, we can take it up now. Yes.
Thank you, ma'am, for such inspiring words and sharing your experience with us. We are grateful for your precious time and effort. I now request the audience to drop their questions, if any, in the chat box or virtually raise their hands.
Okay, I think they are, I don't want to come in between them and their lunch. So.
Yeah, I think everyone has understood the topic very well.
Yeah. Okay.
The link of the feedback form will be shared in the chat box. Kindly fill it before leaving the session. The next session for today, after the lunch break, will be an expert session by Dr. R.S. Tiwari from 12:30 p.m. The link for the session is same and has already been shared in the chat box. Hope to see you all there. Thank you everyone for your time and have a good day.
Okay, thank you, Manas, and have a good day.